Okay, so today's assignment while I'm at the golf meet is for you to work on this packet, which is Unit 8, Practice 3, the mole. And we have to go back and think a little bit about how we calculate something called the molar mass, or how we collect something called the molar mass. And the way that we want to do that is we want to use our periodic table. So if you don't have your periodic table out, you should probably get it out. But we also have to remember that the molar mass comes from the periodic table. So I'm going to write that here. Okay. So, for example, oxygen is element number 8. It's in column 16, and it has a mass of 16.00, and that's grams in 1 mole. So that's the molar mass of oxygen. And you would do the same thing for iron. Down below here, I've calculated the molar mass of calcium chloride for you, but there's a couple of things that I want to highlight. For example, in the formula for calcium chloride, there's no number behind calcium, so there's only one of them, which is why there's a 1 here. And in the chlorine, after the chlorine, there's a 2, so that tells me there's 2 of them, which is why there's a 2 here. So I basically took 1 calcium times the mass of calcium, and I got 40.08 grams in 1 mole of calcium. I took 2 chlorines times the mass of chlorine, which comes from the periodic table, and I multiplied that by 2, and I got 70.90. So then to get the total molar mass here, I simply added these two things up. So 40.08 plus 70.90 gave me the molar mass of 110.98 grams per mole of the compound calcium chloride. The other one that I wanted to highlight is aluminum hydroxide. And so the aluminum hydroxide, again, aluminum right here, there's only one of them, which is why there's one here. Oxygen is inside the parentheses, and there's a 3 outside the parentheses. So that 3 distributes itself to the oxygen. So it's 3 times 1 oxygen to give me my 3 oxygens here. My hydrogen is inside the parentheses, but the 3 is outside. So it distributes and multiplies itself by the 1 hydrogen there. So 3 times 1 is 3 hydrogens. I then went and located the masses on the periodic table for aluminum, oxygen, and hydrogen. I multiplied aluminum by 1, got 26.98. I multiplied oxygen 16 by 3, and I got 48.00. And I multiplied 3 hydrogens by 1.01 for the mass of hydrogen, and I got 3.03. I then simply added those things together, and I got the molar mass of 78.01 grams in 1 mole of AlOH3. The other thing that I want to highlight for those of you that are going to take a look at this and work on this during class is that, for example, iron sulfate, there's a 2 back here, so that tells me that there's 2 irons. There is a 3 outside the parentheses, but there's nothing behind the S, so that would distribute to the S. So that tells me that there's 3 sulfurs. And then there is a 3 outside the parentheses and a 4 inside the parentheses for the oxygen. So I'm going to multiply that, and that's going to actually give me 12 oxygens. So just some things to think about as you're doing the molar mass for this particular part of the assignment. The other thing that we need to remember and think about is the relationships or conversion factors between atoms, particles, and moles. And so what we need to remember here is that 1 mole of anything is going to be equal to 6.02 times 10 to the 23rd particles, atoms, or molecules. The other conversion factor that we have to be able to remember is that when we're looking at the relationship between grams of magnesium and moles of magnesium, the relationship is always going to be 1 mole of magnesium is going to be equal to the mass of magnesium. Again, that mass is going to be on the periodic table. And the mass of magnesium is 24.31 grams. So again, remember I got this from the periodic table. And So now that's my relationship. The next thing that you're supposed to do is you're supposed to draw the mole flow chart below. And what I want to show you here is that in my answer key, look at all that. Here's my answer key. So, and I'll post this copy of the mole flow chart on Google Classroom as well. But what I want you to see is that that's probably too big. Is that the mole flow chart right here has mass and moles and particles. And particles can be atoms or molecules. So if we're going to go from mass to mole, we would use this math here. If we're going to go from mole to particles, we would use this math here. And I'm going to talk a little bit more about this in the next video. But that was some hints on how to work through the first page. And so I'll start another video for the next page.